LVM rules. In first part, I have uh, told you the 11 rules are there, right? Related to the LVM.
Yes, right.
Okay. Yeah. So today we'll see how to break those rules. Okay. LVM. So first we'll check types of VG. Okay. So in AIX, different types of VGs are available, and depending on a VG, we can add the number of PVs, we can create the number of LVs, and the it defines the PP size also. Okay. So types are normal VG, then big VG, and scalable VG.
Okay.
Big VG and scalable VG. Scalable. Okay. So in a normal VG, how many PVs can be added? So maximum 32 PVs we can add. Maximum 256 LVs can be created,
Okay.
and maximum PP size is 1 GB allowed. Okay. Minimum 1 MB, maximum 1 GB.
Okay.
In big VG, 128 PVs can be added, and 512 LVs can be created, and maximum PP size allowed is 1 GB.
Okay.
And in scalable VG, it's 1024 PVs can be added, 4096 LVs can be created, and maximum PP size allowed is 128 GB. Okay, so if you have a server on that, if you want to store maximum data, you can go with this scalable VG. So scalable VG, it is rarely used actually in environment. Okay, so number of PVs, then here number of LVs, and here max PP size. Okay, maximum PP size. Okay, so can we convert this one from normal VG to big VG? So answer is yes, it can be converted. So to convert that one, command is chvg hyphen capital B and the VG name. If we fire this command, okay, we can convert the normal VG to big VG. Okay, basically when we fire the MKVG to create a new volume group without any flag, it creates the normal VG. Okay, and later, if we required, we can convert it to the big
Okay.
VG. Okay, then if you want to convert the VG to the scalable VG, in that case, now, first of all, we need to vary of VG name. So when we vary of VG, actually downtime is required for that. Okay. Then chvg hyphen capital G and the VG name and the VG name. Okay. And once it is converted, then we can bring it online. Vary on VG and the VG name.
Mm-hmm.
Okay, so these commands we have to fire. Reverse is not possible. Okay, you can convert normal to the scalable directly. Okay, but scalable to normal is not possible. Big to normal is not possible. If you want to do that, then you have to destroy the VG and you have to create it freshly.
Okay.
Okay, great. Then there is a concept called as VGDA, that is volume group descriptor area. Descriptor descriptor area, and volume group descriptor area, basically it contains the complete volume group information. Okay, in AIX when we fire the LSVG VG name, okay, it shows the complete information of a
Mm-hmm.
VG, right? It shows the VG name, how many PVs are there, how many LVs are there, what type of VG is it, then quorum and other stuff it shows. Okay, so actually it reads the information from the
Mm-hmm.
VGDA. Okay, so about VGDA in AIX, there is a very important interview question. Okay, so to understand that one, you should know the structure of the VGDA. So I'll open the MS Paint. Okay. Uh, Now, interesting thing over here is VGDA is very important part of the AIX operating system or the any volume group, I would say.
Mm-hmm.
Okay. So if the VGD is corrupt, we will not be able to access the VG.
Mm-hmm.
Okay, if the VGD is corrupt, will not be able to access the VG. So VGD is so important. That's why in AIX, if we have one PV in a VG, Okay, if we have only one PV, in that case AIX creates two copies of VGDA, two copies of VGDA. Okay, because it is very important. Okay, so it creates two copies of VGDA. So if we have one PV in a VG, then two VGDA copies gets created. Okay, then if we have two PVs in a VG, in that case in AIX three copies of VGDA will get created. Okay, this is the automatic thing, but you should know this is the interview question. Okay, so two PV in a VG, it creates three VGDA copies. How it gets created? So here VGDA, one copy over here VGDA, and one more copy over here VGDA. So total three copies will get created. Okay, clear about this? And then if we have three PVs in a VG, three PVs in a VG, in that case three VGDA copies. Okay, so in normal VG maximum 32 PVs can be added. That means maximum 32 VGDA copies can get created. Okay, but this is the interview question. VGDA, VGDA, and VGDA. Okay, so if we have three PV in a VG, three VGDA copies. VGDA copies. So here, if we have one, two VGDAs, if we have two, three VGDAs, and if we have three VGDAs, if we have four VGDAs, like that up to 32 VGDAs. Okay, so this is the structure of the VGDA. Yes. Clear about this? Oh, great. So in AIX, there is a concept available on this VGDA, that is quorum. Okay, so let's see what is quorum actually. So for easy understanding, quorum is basically it is the inbuilt software to monitor the VG health by checking the VGDA availability. So it is the inbuilt tool available in AIX operating system. Okay, so instead of software we can say tool to monitor the VGDA health, to monitor the VG health by checking the VGDA availability. Okay, so how this quorum works? So basically, if the quorum is enabled, if the quorum is enabled, our VGDA availability should be more than 50%. Should be more than 50%. If it is not more than 50%, okay, this quorum will bring the VG offline just to secure your data. Okay, so that's why your availability of the VGDA should be more than 50%. Now, to enable quorum, command is chvg hyphen capital Q small y and the VG name. Okay, and to disable quorum, chvg hyphen Q small n VG name. Okay, so if you give the Y flag, it will be enabled, and if you give N flag, then it will be disabled. Okay, great. Then there is a concept called as T factor. T factor. Okay, so there is no full form for the T actually, but what happens actually, T value is a 2 raised to 0, that is 1 actually. Okay, T value by default is 2 raised to 0, that is 1. And when the t value is 1, in VG we can add 32 PVs, okay, and in a single PV 1016 1016 okay 1016 PPs per PV allowed. Okay, so if you want to have more PPs in a PV, okay, you have to change the T value. Okay, so to make this T value equal to 2, you have to fire the command chvg hyphen t 2, okay, and here VG name. What happens actually after firing this one? After successful execution of this command in a VG, 16 PVs can be added, okay, and it is inversely proportional to the PP count. So 2032 PPs per PV, okay, 2032 PPs per PV can be created. Same way, we can change the T value to 4 also, that is 2 raised to 2, and here hash chvg hyphen t4 and the VG name. Okay, so what will happen after firing this command? In a VG, 8 PVs can be added. Okay, and here 4064 PPs per PV can be created. Okay, got the concept about P factor? Great. So in AIX, there is a concept called as P factor also.
I mean, P factor is like a parameter, na?
Yeah, Sachin.
It's like a parameter.
Right, it's a parameter.
Okay.
Okay, great. Then in AIX, P factor is also available. You will not find P factor on Google or in any documents. But if you do the man page of a CHVG, okay, in that P value is mentioned. Okay. In real-time environment, very rarely P factor is used because it works with the scalable VG only. And in market, there are very few customers who uses this P scalable VG actually. Okay, so now let's see the intent question: how to migrate root VG from one PV to another online. Means without downtime in AIX, we can migrate the operating system from one hard disk to another hard disk. Okay. So for that, first of all, we should have a basic information with us, and that basic information includes the LSVG root VG. We should have this one. Then LSVG hyphen P root VG. It shows how many PVs are there actually in a VG. Okay. Then LSVG hyphen L root VG to see the logical volumes. Okay, and then let's say we have added a new disk into the VG. Okay, after adding that one, cfgmgr command we have to fire to detect that one. Okay, so let's say new disk name is as disk 7. Okay, for our understanding. Okay, and then first thing we need to fire the command extend VG root VG and HDisk 7. HDisk 7. We have to add the HDisk 7 in a root VG. Okay, and then once it is added, we can fire the command migrate PV /dev H disk 0. Let's say H disk 0 is the disk
mm,
which contains the root VG, and slash dev
7.
H disk
Mm,
7. Okay, that means migrate whatever the data is present on hard disk 0 to the hard disk 7. Okay, once the migration is successful, then we have to fire the command boss boot -ad on h disk 7. Okay, this command will basically create the blv, okay, boot logical volume on h disk 7. Okay, blv on h disk
mm,
7. Okay, once it is created, then we
mm,
need to change the boot list, right? After migration of this one, we need to make
mm,
the first boot device hard disk 7, because hard disk 0
mm,
we have migrated everything, right? So in AIX, to change the boot list, command is boot list -m normal, okay, and h disk
mm,
7. Okay, so this is the command to change the boot list. To change boot list, okay, and then you can remove the h disk 0 by using the reduce vg command. Reduce vg root
mm,
vg h disk 0. Okay, and once it is removed successfully, to test that one, you can fire the command shut down -fr, just to test
mm.
whether the activity is successful or not. So let's fire the command root. Okay, password I have changed. Okay, so it's del at 123, it's capital D. Okay, now let's see lspv command how many pvs are available here. So we have root vg, hard disk 0, hard disk 2 are visible. Let me check this one. Yeah, correct. Virtuous, because it is the helper actually created on this. Okay, so first of all, we'll see which command what we covered. Okay, normal vg, big vg, and scalable vg. Okay, so first we'll try to convert it to the big and then scalable. Okay,
Hello?
lspv. So what is the command to create a new
MKVG, na?
vg?
MKVG or MK. Hello?
Sachin? Yeah, what is the command to create a new vg? Yeah, mkvg -y. Okay, Sachin vg and hdisk 1. So this hdisk 1, sorry, it's not hdisk 1. Hdisk 0 is free, right? Hdisk 0. Okay, so you can see that Sachin vg is created successfully. LSVG and Sachin VG. You can see that complete information is available. So actually, it reads the information from the VGDA. Okay, so you can see that volume group name is Sachin VG, state is active, read write operation is allowed. Then maximum LVs can be created 256, and total PPs created 479, size of the PP is 32. So system has selected it by default. Okay, and quorum it is enabled. Okay, quorum is enabled, and maximum 32 PVs we can add. Maximum value is 256. Let's convert this one into the big VG. To convert that one, chvg hyphen capital V and the Sachin VG. So if we do the conversion, LSVG Sachin VG, you can see that you can see where is that maximum value is 512
Mm,
and maximum PV is 128. Correct? 128, 512. Okay. Then, if you have to convert it to the scalable, command is chvg hyphen capital G and the VG name. So Sachin VG, enter. So you can see that the volume group must be varied off during the
Okay.
conversion to the scalable volume group format. Okay. So here you can see that steps are vary of VG, then convert and then vary on. Okay. So first thing, vary of VG, Sachin VG. We need to vary it off. Then fire the command chvg Sachin VG. After conversion, it cannot be imported into the AIX 5.2 or lower version. You would like to convert? Yes. It is changed successfully. LSVG, Sachin VG. Oh, sorry, vary on VG,
Okay.
Sachin VG. First thing we need to vary it on and then fire this command
Yeah.
LSVG, Sachin VG. Okay,
Yes.
clear about this. So
Mhm.
here you can see that maximum PVs can be added 1024. Okay, LVs it is showing 512 because
Okay.
size of the PVs here added very small actually. That's why LV count is not changed here, but it's 4096 as per the document. Okay, great. Then next is what? Okay, how to enable and disable the quorum. Okay, so command is chvg hyphen capital Q small y which you name to enable that one
Quorum
and
is
to
enabled.
disable hyphen capital Q small n. Okay, so we'll enable and disable that one. So right now it is enabled, right? Let's disable this one chvg hyphen capital Q small n and we search in vg.
Hmm.
Then lsvg. It is disabled, correct? And to enable this one, command is chvg y and then
But
lsvg.
what if quorum is disabled? So in the quorum is
Okay, it is
disabled,
enabled
then
now.
we are not able to trace
Got
any.
it?
We are not able to monitor the or trace the VG na, in case
Mm-hmm.
of quorum is disabled. Hello? If in case anything goes wrong, we are able to. Okay.
Right,
Okay.
right. Correct. So it will not monitor the VGD availability.
Okay. Okay.
Okay, so even if it is less than
If
50%,
quorum is
okay,
used,
it
VGD
will
is
not
less
bring
than
your VG
50%
offline because
only.
it is not
If
checking
less
the
than
VG head.
50%, we are not going to
Okay,
monitor it. This AX is not.
yeah, great.
If VGDA is greater than 50%, then only quorum we can enable the quorum. No?
Sorry, sorry.
If the
Come again.
VGDA is less than 50%, then we are not going to monitor the
Mm-hmm.
VGDA. Hello?
Correct.
Okay. It will get offline.
No, quorum will bring your VG offline automatically. Yeah, because it is already in enabled
Hmm.
state, it is continuously monitoring that one. And once the VGDA is less than 50% to save your
Okay.
data, okay, to
In
keep
what case we
your
use
data
this
safely, it
logs
will
of
disable the
this
VG
is an
actually.
inbuilt tool, but in what case we use this tool,
Okay,
quorum?
yeah, okay. Basically, look, as I said that, uh,
Okay, yes, yeah.
one minute, where was that? Okay, if we have one PV, okay, in case of one PV, two VGDA copies are there, correct?
Okay,
So in that case, quorum is required. Okay, because even if one of the VGDA goes bad, In that case, your data is at risk, correct? Okay, but if you have four hard disks, okay, with four hard disks you get four VGDS copies. Okay, in that case monitoring is not required actually. Okay, because even if one goes down, still it is
Okay.
more than 50%. If another goes down, it's
Okay. Okay.
50%. You have still two copies available over there. So when your VG contains less number of disks, quorum is required. Okay, great. Then what do we have here? We have here. Okay, let's see what is T factor. Now here, if I fire this command, okay, we have converted to this scalable VG, right? So that's cool. chvg hyphen t2 and the such vg, if I fire, it will throw the error
Yes.
because the T option is not valid for the scalable volume group. As I said that with the scalable volume group, P option is available, not T option available. Okay, so to the P option, we call it as a P factor, but in documents you will not find that concept because it is rarely used. So for that, what we need to do, we'll do one thing: reduce VG, Sachin VG, and disk 0. Then we will create new VG, MKVG hyphen Y. Let's say sample VG is disk 0. And okay, it is created, so lsvg sample vg. Okay, sample vg. So here 32 and 256, okay, and 1016 pps per pv, correct? If I fire chvg hyphen t2 and the sample vg command, after firing this one, you can see the difference, and the difference is with this 2032 pps per pv can be created, and maximum
Right.
pv is 16.
Yes.
Okay, so it doubles the count of a pp per pv, but it is inversely proportional to the pv count. Okay, got the concept? Great. Then for migration, 1 minute lspv rootvg. Rootvg, here we have telnet. This is 5 GB hard disk. LSVG, root VG. In a root VG, the used is 4 megabyte. Okay. So, okay. Let's see how to migrate the root VG. Okay. Now,
Okay.
okay, we'll try this one. Okay, if
Okay.
activity, is not successful, it will bring this alpha down. Okay, so to up that one again, it will take some time, but we'll try that. Okay, so lsvg hyphen p root vg. Here, hard disk one is present, so we'll add hard disk 2 in that. Okay, to add that one, extend vg root vg disk 2. Okay, so it is added successfully. Hard disk 2 is part of root vg. Then I'll fire the migrate pv command slash dev as disk 1 slash dev as disk 2. Okay, okay. Did not complete all pv partition have not been moved off, was not found. The physical volume dev as disk 1 was not found in the system database. one. Okay, boot info hyphen s is this 0. Boot info hyphen s is this. Okay, so showing is
Okay.
this one. Okay, we'll perform this activity later
ठीक है.
because in last means in other trainings we have migrated it already. Okay, so that's why it is giving the error, but we'll check it later. Okay, so yeah, boot list hyphen m normal hyphen o is the command to check the boot list. So hard disk one
Okay.
is the first boot device. If you want to change that one, command is boot list hyphen m normal, and the new disk name you have to put over here. Okay, great. Then sample vg. Okay, so ls vg command I'll fire. So sample vg is visible, and if I fire the export vg sample vg command, it will not allow me because it is varied on. So first of all, we have to vary of vg sample vg. Okay, and then export. Okay, so once the export is successful, you can see that on hard disk 0 it is showing none. Okay, because our ODM is not able to read anything on a hard disk 0. Okay, but data is still present on a hard disk 0. Clear? And in same machine we can fire the import vg command. Import vg sample vg with h disk 0. So for that, import vg import vg hyphen y sample vg h disk 1, right? No, no, sorry, 0. Great, so it is successfully imported now. You can see that it is back again. Okay, for testing purpose we can export it from the same machine and we can import it on the same machine. That's not an issue. Okay,